So good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. My name is still Francesco Petruccione, like every Monday, so no change on that front. And today I have a very big honor and pleasure to introduce to you Professor Delia. Delia was a colleague for many years at UKZN, but she was at UKZN long before I moved to UKZN. Yeah. And she's still at UKZN. Yeah.
That's right.
And not only she studied at UND, which became
Yes, I was UND.
which became UKZN at some stage. Yeah, and she's been head of department, dean, almost all executive positions that you can imagine. Yeah. And statistics education is, I think, one of her passions.
Yes.
And she's been very active in that respect with a lot of important functions that maybe I don't read because I assume that all of you can read. Yeah. So, Delia, we're very glad to have you here to give us a personal account of what we need to do to save statistics education and data education in the country and probably worldwide. Yeah. So,
Thank you,
Delia,
Francesco.
thank you very much for coming. Thank you.
I'm most grateful to Professor Petruccione and to NITheCS in particular for this wonderful opportunity to speak to you today. Thank you very much for the introduction. Professor Petruccione has alluded to, I have been in statistics education for a very, very long time, for around 4 decades, where I progressed from being a statistics tutor through to leadership positions at my institution in my discipline statistics, but also nationally through South African Statistics Association Education Committee, and then on the International Association for Statistics Education. I've had a number of leadership roles there, and somehow I've just absolutely enjoyed every minute of my work that I've done for statistics education. So really, as you can see from the title of my talk, I'm going to be talking about opportunities and challenges for statistics education in the data era. There are many challenges, but there are also many opportunities. And it's a personal account, meaning I'm not going to, in general, speak about opportunities and challenges. I'm simply going to highlight the challenges that I saw and what I did with those challenges to make it an opportunity, not for me in particular, but for my discipline at my university, and then show you the effect thereof. So that really is what my talk is about. Oh, that's a bit fast. We're in the data era, as you know. So massive amounts of data are being generated, collected, analyzed daily due to all the digital technologies, internet, smartphones, and so on, other sources. Estimates may vary, but this is really very profound for me. It's been estimated that more data has been generated in the last 2 years than in the whole of human history. Now, if you think about that, it is absolutely amazing. So we cannot teach in the way that we always taught. I certainly don't teach in the way I was taught 35 years ago. So today, the ability to analyze the data in real time and to be able to do predictive analysis will allow business to better serve their customers, to increase competitiveness, and so on, so that companies treat data as a very valuable resource because it gives them competitive advantages when they can use their data to maybe change the course of the company or to inform their future strategies. It's extremely important. Citizens, on the other hand, with basic data literacy skills are better equipped to navigate and succeed in their personal, professional, and civic lives. I'll give you a very simple example. The lady that works for me in my house is not schooled, maybe past grade 10. She took her baby to the clinic and they told her the weight and she had to look at a percentile little graph. It meant absolutely nothing to her. So it's really important, even if you look at the Stats SA data that they give out, it's really important that everybody has a basic idea, even if you watch sport. They talk about run rates and they've got various graphs. People nowadays need to be able to read not just read graphs and facts and figures related to data and to understand what it's about. But there's a shortage of skills in data analytics at all levels, right from basic statistics literacy for the man in the street to high-end statistics needs for citizenship, from data statistics, data analytics, data science, research skills. All of this is needed. And the talk really is about what can we do to ensure that more young people go into statistics, data science, data analytics of whichever kind, because it's an international problem. But the problems related to building these skills in data analytics and data science is everywhere in the world. But here's the important thing. The problems are more pronounced and more urgent to resolve in developing countries. This last statement about shortage of skills in data analytics at all levels, from the basic statistics literacy needed for citizenship to top end research skills in data science and statistics. That shortage is a problem all over the world, but it's international, but it's more pronounced, it's worse in developing countries, and it's more urgent to find a solution. This statement was made by Helen McGillivray, president of International Statistics Institute, and I quickly wrote it down. And also, she was president of International Association for Statistics Education. And for me, it was so profound when she said, you know, I sit here and I know what the problems are in my country and I worry about it. And then she says, it's everywhere in the world, which I know, but it's more urgent that we solve them in developing countries because there's such disparity in income between people and there's so many opportunities for employment if you study statistics and data science and so on. But our unemployment is still very high. So yes, we need to resolve it. So that's really what this talk is about. And I'm going to be talking about projects, initiatives, and various ideas I've had and maybe that I've followed up on that others have had in statistics education, because there's so many challenges to creating, to getting the statistics education correct in our country. There's so many challenges, but every challenge is also an opportunity if you face it in the right way. If there wasn't a challenge, then everything would be fine. If there are big problems, you need to see what others are doing. And that really was my strategy from the beginning. Go to as many international conferences as I can because of what Professor Helen McGillivray said. She said, everybody's struggling with this, but it's more urgent that you solve it in developing countries. So I went to as many international conferences as I could to try and see who's doing good work. And then the important thing, bring it home to South Africa, but you can't just copy it, because we are the only ones that live here that know how it would work in my country. We don't have a postal system. You know how difficult it is. There are things that are different, that's unique to our country. So we can take international best practices, but then we must know how to tweak it or how to change it for it to work in our country. And that's really what this talk is about. Every challenge is an opportunity, and it's obviously an opportunity for growth and being pretty good for me. So let's start at the basics. Why did I become a statistician? Well, I was good at mathematics at school. I love problem solving in a realistic context. So it was maybe why I did statistics, but no, I found statistics by accident. When I went to university a very long time ago, nobody spoke about the word statistics, but computer science was new. And I was told about computer science. And computer science, they said, is a kind of mathematics. So I thought I'll do computer science. But computer science had those card machines, and we had a huge computer that took a whole floor of a building, standing computer. We didn't have little individual computers. So it wasn't much fun. But if you did computer science, you were forced to do 6 months of statistics. And that's why I did statistics, because I did computer science and I was forced to do statistics. And when I did it, we just had calculators and small data sets. It wasn't really exciting. But then we did a lot of probability. And probability, we did a lot of theory. It was called mathematical statistics in second year. And I said I like mathematics. So obviously I enjoyed the probability in particular and went on to do my PhD and measure theoretic probability. So I enjoyed the theoretical part, but that was in the days when data wasn't as abundant as it is today. So today it's quite different. So how did it work out for me? Well, it worked out pretty well. I've got a profile at my university, national, international, and so on statistics education. And that's really because there was a data revolution. I was just lucky that this subject that I did, because I was forced to do it when I did computer science, later became the big thing with the data revolution. Now statistics at my university is huge, but it wasn't when I was a student. I'll tell you how bad it was, and it actually is part of the reason why I did postgrad. Prof. Tertius de Wet is here, he knew me in those days. And in my young days, do you know that when I was in third year, we were about 30 students doing statistics and mathematics. No one was doing honors in statistics the following year in my third year. And I was begged to be the one to do honors. And then they told me that for 5 years, no one had done statistics honors at UND. Please be the one that will do it. Can you believe it? That's how unpopular statistics was in those days. But I enjoyed probability and I carried on. And as I said, I did my PhD. But I was a single person in honors class in those days. Now we have so many applicants, more than double the number we're allowed to take. So the world has changed in a good way. And also now statistics is needed by, sorry about that. Okay, statistics is now needed by all disciplines, and the abundance of data has totally changed, totally revolutionized statistics teaching. But here's the problem. You won't believe it. I taught honors maybe 2 or 3 years ago, and I asked my 4th year class, who came to university saying, I want to do statistics? They're now in 4th year doing honors. They're all specializing in statistics. Do you know there wasn't one? Still in this day, students that come into university see statistics in their handbook, and they do not even in the data age know that that is what in the school curriculum is data handling, which is in paper 2, and probabilities in paper 1. I know because I was part of the national work group that did this school writing of the curriculum when it came in 2005. So it's very sad that even in this day and age, students do not come to university knowing what statistics is, but they often find it by accident. So that problem is still there. And that is also what this talk is about. So data era, we're in an ever expanding data world, and statistics as a discipline is challenged to chart a way into this ever evolving data era. So we need some clarity of thought on what is the identity of a statistician and purpose, because it's vital for everybody who teaches statistics to push the boundaries of the discipline, because we're still going to have research statisticians, but what is different? What should we be doing different? We certainly should be producing more statisticians, and we certainly should be telling them at school about it, that we know. But what more can we do and how should we do it? Well, there are various challenges. Ever-evolving world of data. Methodology must keep up with practice. So we need our research statisticians, but they must be ready to keep changing the type of research they do as well, because the data world is not static. It changes very quickly. We need to massify the number of adequately trained data specialist graduates into the workplace. We cannot just have people in other disciplines that can't find jobs that then become the statisticians at the companies. We have to massify the specialists, and I will talk more about that just now. Academic systems, sadly, are slow to respond. Anybody that's a dean or a head of department, and I know there's a few sitting here, it's really difficult to change a curriculum. But we do have our data curricula because the data world changes so quickly. So we need to be on top of the change. We can't sit here until we finally realize things have changed. Go to international conferences, see what the changes are, try and be ahead of the curve. And that's what we've tried to do. And I'll show you how we did it as well. But we also have a high risk of losing experienced academic statisticians because industry is so desperate to get good statisticians, people that are good at data analytics. But at the same time, there are too few academic statisticians at university. So to hold on to your academic statisticians is difficult because obviously they get paid the same as everybody else, maybe a tiny stipend as a scarce skill, but just not enough to be able to compete with what industry can offer. So yeah, we do have lots of problems, and our academic statisticians are highly mobile. And they do move around, and it's really sad, but fact. Then the biggest one, difficulty in attracting school graduates to study statistics, data science. I've already told you why. Probability and data handling were separated into paper 1 and paper 2. You know, like algebra, trigonometry, and geometry. At school, we taught totally separately in different books. That's how they do data handling and probability. They never put the two together. And it's very sad, but that's the way it is. So, statistics. To be able to think what is the way forward and how should we approach the problems I've been talking about, we have to really get to the foundation and the strength of each. Statistics has been around since about the 17th, 18th century, really strong history, rooted in mathematical theory. Mathematical statistics is what I certainly did my postgrad studies in, theory and probability, focus on drawing conclusions from data using rigorous methods, theoretical, rigorous methods, and we need that at the base of our discoveries, even in the data age. The strength is there are clear rules for making decisions with limited information. We use probability, we can make rules. Now, data science is very much also prominent in the data age for analyzing data. It integrates statistics with computer science, machine learning, and domain knowledge. Statistics is there. Excels at handling massive unstructured data sets, making predictions using machine learning models. So really, statistics, data science, statistics is within data science, and as you'll see from the next graph, I know there are many. This is the one that I like most. It maybe puts it all together. In the data science era, we want to produce statisticians that work with domain specialists, meaning with whatever industry they're in, they specialists, they're engineers, whatever, and then with computer science and coding and so on. And the statisticians, our statistician graduates must be able to, in the workplace, lead such teams. In the fast-changing world of data, it's going to keep changing. But at the same time, they must further the discipline of statistics in the data era. So it's got to do both. So we need upskill our teaching of statistics in the data era across all levels. From basic statistics literacy needed for citizenship, it means for the man in the street. He must be able to watch cricket and know what a run rate is and be able to look at a graph and understand what's going on. We must have graduates that can hit the road running in the fast-changing world of data. And I don't only mean statistics graduates. Graduates anywhere, in every discipline, should have some basic statistics knowledge. Even maybe your journalist should know some, statistics for word searches and so on and so on. Research statisticians that can continue to push the boundaries of data analytics in the fast-changing world. We still need our top-end researchers in statistics. So how to do that? So this now is about reflections, considerations, leading to aims and directions. I've told you about all the problems for statistics education to increase the uptake of statistics at all levels, to boost knowledge production for the data-infused workplace, and to build core knowledge in statistics that is relevant for the data age. So I'm now moving to, these are all the problems. What have we done? Or not just what have I done because I'm so clever. I went to so many international conferences, saw what the talk was, and then thought how to adapt it. How can I do it for our university and for our situation? So that really is what this talk is about. What's important to me is good teaching. Good teaching by an enthusiastic lecturer must be fit for purpose, fit for the data age, but also be well delivered. And we do statistics training across the full data skills value chain. We worry from the man in the street to top-end research. What can we do? And I'll tell you what we did at my university. And when I say my university, I'll tell you soon, it's not just me, many of us work together. We need clarity of thought on the purpose as statistics educators. What are we trying to achieve? We know our aim has always been and still is to empower people to better collect, source, and learn from data. There's just a lot more data around now. To protect themselves against this and misinformation. Today, we further have to prepare our students for a world subject to unforeseen disruptive changes that will make many of their hard-won skills irrelevant. So when they've left university, they mustn't think that's it, I'm a statistician. You're going to have to keep learning new things because the data world changes very quickly. But then we've got to build in them resilience or confidence or adaptability. If you've got parents, we were talking earlier on, If you've got parents, particularly of sportsmen, it's tough. Any job is tough now. The statistician job is really tough. You've got to be on top of your game, and you've got to know where the changes are, because there will be changes. And just when you think you know, there'll be new changes, and you'll keep going. So you've got to know how to be confident and how to be adaptable. So what did we do to make our students more adaptable, and so on and so on? So what's the role of statistics in the modern era? As a precursor to the broader field of data science, statistics forms the core foundation of data analytics. There's no doubt it's been around since the 17th and 18th century. Data science really came about in around 20,000, in the 2000, because of the big data. So statistical principles are integrated into machine learning algorithms, contributing to development of advanced analytics in the data zero. Statistics emphasizes ethical consideration in data collection and gathering, and gives us unbiased use of information. I think I've said this. Guiding principle. Here's the important thing. If you think like a computer, you'll be replaced by one. So we've got to get our students to understand the basics, the theoretical basics, but then to be able to adapt as things become interesting. Essentials to bring home to students. They must be well versed in experiencing everything is changing. A constantly need to learn new things, and that's just the way of life. So they need to be lifelong learners. They must develop dispositions that promote big picture interest, what really is going on, so that when things change, it's not just such a surprise. Opportunities are easier to spot. They must respond to challenges, slotting into problem solver mode, rather than saying, I wonder which theorem, which distribution. That's how we used to teach in the old days. It's not like that. They need to have a much bigger picture approach, but they need a solid grounding in the discipline as a whole. They must avoid despair. I'll never be able to cope. If you've got children, life's tough. They need to have some opportunities to battle on their own, to build up the confidence that they can overcome, but obviously just with little bits of help along the way. Because in the middle of difficulty lies opportunity, but it requires confidence born of past success. So how do we give them this kind of experience in a large class? You've got 120 in third year. How do you build these skills? And I will be talking about that just now. So what's got huge long-term value? Obviously, we have to have some students that are research students. They're able to devise new recipes, procedures, algorithms, theories, models. At the top end, they are researchers in statistics. But another long-term value will be the ones that can use those theories and so on, and recipes, to uncover, navigate trends, patterns, using appropriate recipes. These are the ones that are making the recipes. And here's the good news. A small pool of people need to do that. Those are your researchers. But a lot of people need to be able to use the models and whatever we're using, the methodologies. So this is where your research statisticians are working. And this is where everybody else, all the service courses and so on, must know how to use the procedures and theories and so on. So this is now we're getting to the point where I'm telling you what my university did. So all of this was just a build up to say, okay, we know all this. We went to lots of conferences. What did we do? What did we do to try and address these things? Because we did a lot of stuff. And before I go further, as Professor Petrocini said, our university, I'm at UKZN, and it's a merged institution. I was dean and head across more than one campus, and statistics falls within mathematics, statistics, and computer science. That's like a school or a mini faculty, which is in this college of all the sciences. So now, this, even just statistics, is not just on one campus. If you've got a new idea, and I'm talking here about new ideas revolutionizing teaching of statistics, you get a new idea. Everybody wants to do what they always did because that's no work. I've got my notes. You try and get people to change their and throw away their first year notes and teach totally differently. It's not easy. Now you try and do it on 2 or 3 campuses. You already got a problem there. Now you got to try and get it to work in your school. And there are people in other disciplines that will shoot down whatever you do just for the sake of it. It is hell. But somehow we managed to do it, and we got it all the way through. and we introduced some new programs because we just kept pushing. Every time they pushed me down, what I kept saying, I know what I'm doing. I've got a plan of action. I want an industry integrated data skills development program. I'm going to take kids from school in abundance. I'm going to tell them what statistics is. I'm going to show them what statistics is. And then I'm going to teach them well so that they get employment. Because I don't accept this underemployment. So many people are unemployed when there's such a need for data skills. Why don't we just teach them basics of data? So that really was the plan. So we want to build a reputation that we've got relatively trained graduates that have at all levels in data analytics. And we went to so many conferences to look at the best practices, latest developers, internationally, nationally, because I've got various roles I play internationally, international conference teaching of statistics. I've done a lot of stuff there. So when you've got lots of people, you know, you've been on many committees, and I went to World Data Forum. So this is held every 2 years, some of these ISR conferences. ICOTS is every 4. I've gone to many, many of those. And that is where I built up a network, not just of seeing what people are doing, being part of structures so that you can utilize the other people, because they always want to help developing countries. And of course, SASA as well. And then comes Professor Zewata, who is a statistician at my university. He and I work very closely together. He was top researcher of the entire university across all faculties and colleges in 2020. He's the elected member of the International Stats Institute and particularly of the Data Science Committee. That's very relevant. So it's great to have Temescan with me. And also the Data Science Center of Excellence at Rwanda University. He's an advisory panel member. He's on the ISI committee for data science. He's an ISI Data Science Committee member. ISI is the biggest stats thing in the world. So for Prof Zewata to be such a top researcher and to be with me, and I've got a big footprint in stats education. Together, we started a data science unit for business and industry. We said we want a unit where we will link with industries, and we know exactly what we want to do all these education things at the different levels. So the first thing we did, we said, let's find a software developer. SAS Global Academic Program interested me. Over 3,000 universities worldwide. They've got a campus with 9 buildings that makes all the software continuously. So we signed an agreement with SAS. And that gave us opportunity to go to top universities that have linked with industry. Here they are, including Cincinnati, North Carolina. There are quite a few others. I've just mentioned these because these are the ones we personally visited, so that we can see what do they do with their PhD program to link with industry. Because once we've seen that, we know we want to do that. What do we have to do lower down? Because the big thing I want to do is make sure as many kids at the bottom know about it. So that's really where we started. So we revised all our offerings in statistics, and we defined some data science courses. We planned very carefully using our SAS network, and I'll show you some. So as I said, we went to many universities, including Michigan State and so on and so on. So that helped us. So what we really wanted to do, we know there's an industry shortage of statisticians. We know that there are many students that are graduates, by the way, in disciplines where they don't get jobs. So we wanted to fix this problem. We wanted suitably trained statisticians and academic consultants for the workforce. So what we did, we said, okay, we're going to restructure our undergrad offerings to lay a strong foundation for postgrad study. We've always done that. We know how to build a good PhD program, master's program in statistics. We don't want to lose that. We still want to keep the core of our discipline strong. So we still want to say our undergrad must give the strong theoretical base for postgrad. We're not losing that. So that is still there. So from our undergrad, the students must go to postgrad, where they further the discipline, the research for the data age, research just at the kernel of probability and statistics and so on. We still want that there. But we also, what's new, we say, what can we do to produce discipline specialists for the workplace? And we spoke about it a lot, Temescan and I. We said, we can't just sit here, go to conference and say, they're doing that, we're going to do the same thing. No. We want to say, who are the employers of our students? How can we link with them? Who are the people that are telling us they want our graduates? How can we link with them? What can we learn from them? So then we introduced, and this was based on what I'd seen at all these other universities, we introduced coursework postgrad degrees, and it was hard to get it through the system, but we did. We co-supervise with industry. We've got a PG DIP, postgrad diploma in data science and statistics, and we also have a master's by coursework in data science and statistics. We have co-supervision with industry. When a student does a project for our coursework postgrad degrees, and I'll tell you much more about it just now, they have a supervisor from the university, but they also have a supervisor from industry who meets at least once every second week with a supervisor from the university and the student together meet with the supervisor from industry, because we don't want to at the end hear the solution is not the one we wanted. So they're part of the discussion all along. Project topics come from industry, and they can be internships, and bursaries are available to students if they do these various coursework postgrad degrees. And then the biggest thing for me, that's all great, but the biggest thing for me, by linking with industry, we know what industry wants from our postgrad students, and that informs us how to restructure our undergrad offerings. So we want some students to go on to postgrad and to do these maybe pure research statisticians. Some will do these postgrad degrees that are coursework, but some will go straight from undergrad to industry. So we must know what kind of practicals must we give them? So that is really the new knowledge we need at undergrad level came by linking with industry, because you can't just sit in your office and think you know. You need to work with people that are employing your students to see where they're short, where they know too little, and so on. So there was a really good feedback loop here. And we restructured our undergrad degrees accordingly for workplace entry. So I'm not just interested, like in the old days, for every student at third year to be groomed as if he's going to do honors, to be groomed as if he's going to be a PhD statistician. We still want that. But we've got to somehow balance it with workplace entry. What do they need if straight after that they're going to industry? What do they need? What are the basics? What must we do in the pracs? So that is what we did a lot of. So we got a feedback loop to undergrad. We reviewed our curricula. We balanced the workplace needs and theoretical base to go straight on to research. And we got bursaries from industry. That was rather nice. And that keeps the students in the honors program. And then we definitely want school leavers with awareness. So once we've done this wonderful undergrad changing, now we've got to tell students about it, because how are they going to know? So that is what we did. And then, of course, our restructured undergrad, we put it back and told school leavers as much as possible and told teachers about our programs. We did a lot of school outreach so that the whole system benefits, because if you get more students coming in here, being aware of what we're doing, being aware that they're elevating their chance to get a job, then you get more here, you'll have more here, more going straight to industry, more employment, everybody benefits. So that's really the model. So we set up a kind of ecosystem where each component has influence on the other to be able to get more at all the different levels. So now, the data science program, I'll tell you a little bit about that. We used to have a program called actuarial science. That was before the merger. I was head of statistics and actuarial science. I loved that program. My own one son did it. So what it was is this is it. The actuarial science program is just this little thing here, circle. So what they did is, you can see here, the reds are stats. They did 3 years of statistics, 2 years of mathematics, only 1 module of computer science. And they did a huge lot in the commerce faculty. Well, actually, these were taught by my department. We were statistics and actuarial science. These are theoretical actuarial science courses. And then they did a little bit of financial reporting, they did economics and accounting. Financial reporting is like kind of accounting. So this is what they did. And then unfortunately, when we had the merger with 3 universities becoming 1, some programs were cut. And the actuarial science program was cut. And I was head at the time, and I was very unhappy. But no matter how much I protested, this whole program fell apart. So when we started the data science, the first thing I thought, I'm going to take that old actuarial science and resurrect it. So just call it data science, because we got so much good feedback from all the banks. They were desperate. Our students were already booked up when they were in final year. So I knew if I build my data science on this model, the old actuarial science would be good. But we left all the actuarial science courses. They were from the proper chartered accounting and so on. We left all that out, and we brought in a lot of computer science for the data era. Look how much extra computer science. So in place of these financial reporting, economics, all the commerce courses, the new data science is just the old actuarial science, where lots of computer science is replacing accounting, economics, and the AXA courses. And then they do a bit more maths. So 2 years of maths with the extra one, a lot of computer science, still a lot of stats. So it's really stats and computer science with a lot of maths as well. So that this is part of when I speak to students, you can see I've done yellows, computer science. You're basically majoring in stats and computer science and doing maths up to second year. And then there's an open one. So I've told, for example, astrophysics, why don't they put physics there? And then a student can, at the end of this year, say, do I want to be an astrophysicist? And then they don't have to they generally have to do maths too, if you want to do physics or chemistry. But there's no reason why this can't be physics. It's an open credit, optional, whatever you want to put there. So you can put chemistry or physics there. Do your basic strong 1 year, stats, computer science, and whatever you want to be, a physicist or whatever. And then you can carry on. And after that, you can drop stats and computer science. But at least you've got a strong year of stats and computer science. Because, that is sort of what I always hope people would do. And I've had a lot of flack because at my university, they wanted me to call it DS, data science 1, data science. I said, no, I want it to be the same computer science if you do computer science, so that students can change their mind. Why do you want to block them in when they're first year and make them do data science courses that are different to computer science? They kept wanting me to change stats for statisticians, stats for data scientists. Now I'm like, no, you're taking away people's right to change their mind. So yeah, this is what we managed to finally, with a lot of effort, get through our system. It's all existing. No more work for the lecturers, just more students, no more exams. So we just kept our old courses and we got this through. This is our data science degree. It's versatile because you can still be a mathematician. You can carry on up to second year and then only do maths in third year. That's cool. That's fine. At least you've got a basis in stats and computer science. You can be a physicist, chemist. You can be an astrophysicist. You just change. They only start in second year, by the way. You just pick their physics. Or you can do a combination. There's so much you can do. So what is our plan at UKZN? To build relevant data skills. We got to balance the theoretical base and connecting with the world of work. That really is what we were trying to do. And this is how we did it. This is the master plan of Taniskin and I. So this is what we did. We said we used to just do the top line. You look at the top. This is if you're statistician. Suppose you came here, you're that person that doesn't really exist. You want to do stats. You do a 3-year statistics major. You did a 1-year honors, like when I was a student. Then you do your MSc in statistics. And then you do your PhD in statistics. This is how we used to teach here, as if everybody's going here, then here, then here. We teach you the theory. You're going to move on and become someone that advances the theory, right? This is how we taught, which is really good. But now in the data age, we want employment for our people. We must still do this. I'm never saying that shouldn't be there. Please understand me. We want still the research statistician, the PhD statistician, but we can't only be doing that because that's not where the jobs are. So we want that line, but we want to add extra. Then we said, okay, let's start here. We used to only do the top line. BSc, 3 years, honors 1 year, masters 1 or 2 years, PhD. Now we said we introduced, by linking with industry, a course with masters in data science. And I'll show you just now what the structure is. Basically, what it is 16 credit, 6 courses, and then a very massive industry project. 6 times 16 is 96, so 50% of that degree is a project. And this project has to be from an industry. So this is where they have a supervisor from industry, a supervisor from the university, and it can be 1 year full-time or 2 years part-time. So this really is what revolutionized everything we did. We said, and we got over 400 applicants, by the way, about our third year of running this. It's really huge. We introduced it in 2021. So this is extremely popular. We have people from all over doing this. We teach a lot of it part-time. They do it in blocks. Sometimes they come in for block. But now who can do this? We have our honors in statistics, and then they can do the coursework masters in data science, because we do a data analytics focus. But after you've done this, you can still go on to do a PhD if you feel like it in statistics, but with a topic from the data science world. But it's called, we haven't got a PhD in statistics. We've got a PhD in data science. So you can still do a PhD after that, but on a topic from the data science era, but on the analytics side, and it will become a PhD. So very, very popular. It's boosted our honors numbers 4- or 5-fold, because everybody's trying to get in here. Because here, half of your degree is an industry project. And imagine how employable you are at the end of that. So that is, and the bursaries and so on and so on. But at the same time, we said there's so many students that come to us and they're desperate. And when I set it up, that was what I saw at these overseas universities. They have multiple entry points. So you do the coursework masters, you need an honors in statistics. But there's someone that did 1 year of statistics and then dropped statistics, and now they're so sorry because they've finally found out that they never got a job in whichever fine-pointed area they moved into. So what we did is, at the time of defining the coursework masters, I defined a postgraduate diploma in data science. What is this? This is equal to our honors at the same level, but it's for anybody in science, commerce, or engineering. With other words, they haven't done our honors, but you know how little they do in commerce. They only do 1 module. So if you're in commerce, engineering, or science, you can do the postgrad diploma, but you need to have at least 3 years experience in industry working in the data field. And there's a big portfolio of evidence you've got to put together. So you need to have worked extensively, experience in data, because many people that aren't statisticians from every walk of life in science and that can't get jobs end up working in a bank, but in the data field. So we've got a profile they've got to put together to show that they've worked, they've got a portfolio of evidence, they've actually got a lot of experience in data, they're just not qualified in it. And they certainly haven't done our honors. So then, with your portfolio of evidence, and you've got a degree in engineering, commerce, or science, you put together this portfolio, and we had something like 270 applicants in year 1, and we could only take 20. So we got 20 very good ones, and then they go on to do the postgrad diploma in data science. And when you pass this, you go straight into the coursework masters. Then you're equal to the guiders. So what we do here, we catch the parts of honors that you need. And they do big data projects here. Here's the next thing. Every honors student, remember I spoke about resilience, problem solving? Every honors student at UKZN will struggle with a real industry project in their honors year. Big data, unstructured, difficult problem. Every single honors student here has done it. And I'll show you a little bit more about it. So that's really what we did. And as I say, this is the big one. But another thing to notice here, the postgrad diploma, just like here, 6 16-credit courses, but they have only a 32-credit industry project, meaning equal to 2 courses. So it's really like the honors. Honors, you do 6 modules and a 32-credit course. So it's very much the same. So I hope that's clear. So over 400 applications for data science degrees in 2024. As I say, we can't take 400, so we can certainly take the best. And they're big, they're big. So the projects that we've done, this is our honors students of statistics, not data science students. Some of them will go straight to data science for masters by coursework. Many of them go straight to industry, and they use their projects in their CV when they do talks, when they have to do some kind of talk. We started in 2019 to make sure the honors project normally was free to choose. We don't make it free for them anymore. We force them to do what's not comfortable, to do a big data project. The 1 year we did car tracking, I couldn't tell you the company. We anonymized the data, and they modeled the false alarms that cars send out. You know, when you go over a hump and they say, You get a message, you've been in an accident. So they analyzed, it was huge. Here are the sizes of the files. Every honors student in statistics has done a very big project. In their big 32 credit project is now unstructured data where they suffer so that when they're in the workplace, they can do it. We had a retail company determining size curve that was to do with clothing, different shirts and so on. For the whole country, we had every single item sold by one of the big retail stores. Every day, which company, which item, how much did it cost? You can't believe the size of the... We had huge and so on and so on. Dropout patterns for our university and so on and so on. So we've had really good projects and every single honors student worked on it. And then they use that, as I say, in their CVs, we give them little letters and so on. And our students have even won prizes. One student won a prize a few years ago in the National South African Stats Competition, where they're competing with everybody else, even though they did such difficult projects. So why do we do all this? What's the big driving force? Unemployment. It's really sad for me, and this is, though it's a few years ago, I just have the slide because I did it at the time to do a presentation to a company. Unemployment sector, where nearly a quarter of your university graduates are unemployed. I mean, we're not even talking about the ones that are studied in a difficult science and are now sitting in a bank, which has got nothing to do with what they studied. We're talking about over half of high school graduates that finished are unemployed. What about all the people that aren't even qualified? Something is wrong. And that is really why we put this all. There's such a shortage of skills in data analytics. So why couldn't they just do low-level data analytics somewhere? Who's telling them? No one's telling them. And that's what I feel very passionately about. Statistics is hidden, as I said earlier on. Paper 1 is probability. Paper 2 is data handling. I shouldn't tell you, but it's really sad. Why is probability with algebra? Probability thinking probabilistically, a little bit abstract, it's more like geometry. So I would have put probability in paper 2 with geometry. And data handling, that sort of almost like procedural, should be with algebra. But you know why? They said the paper 1 results are so poor. We can't put, are so good compared to paper 2. Geometry and trigonometry is badly answered. So we can't put probability there. So it just makes no sense. It just doesn't suit where it is. And in any case, the two should be together. Probability and data handling together, statistics. You can't separate. So they taught in different books. Take out your red book, probability. Take out the green book. Nobody puts it together and explains how the two work together. So they come from school, no idea what statistics is. They know data handling and probability, but nobody tells them the two together are called statistics, and there are lots of job opportunities. So when they come to university and they open the handbook and they have to pick, they take what they were good at school. They don't know these words, statistics. It's these two together. And that is part of the advocation I talk about. So what did I do about that? I've had a long history of building skills. Here, what I did is I got Stats South Africa to fund me the 500 worst performing schools teachers. I said, I don't care, anywhere in KZN, 500 worst performing schools. And I want them every Saturday to be brought to this university and I will teach them. Every staff member of mine was involved in that project. We did an amazing, we did it for about 5 years when the school curriculum was first introduced. So this is some of our staff working with me. Yeah, we did some hard work. So we did curriculum design for the DBE, training of subject advisors. They're the ones that teach teachers. Try to get the message to them. We did national workshops, played various games. Those are snakes that you stretch and so on, long story. But bottom line, these are staff members with me. We all work together. It's not me alone. I take the credit because I thought of it. But they work very hard with me. I could never do it alone. And what was this about? Basically, we've had a lot of recognition. But still, the problem still persists because it's so big. So we've done some good stuff, but we want to do more. So what did I do? Went to another conference. What is this woman in analytics? So I heard it when I went to one of the international conferences. Stanford University started the Woman in Analytics in 2020. What is this woman in analytics, data analytics woman? What it is, they were trying to say, women don't get promoted in the workplace, even though they've got strong data analytics skills. They're statisticians, they're data scientists. That was sort of the story. So that was really what it was about. And then I changed the emblem. I made my own logo, which I trademarked, by the way. And then I said, my woman in analytics will be for the schoolgirls to say, you better know what statistics is, because this is your job opportunity. This is, I don't care if you become a statistician, but if you got statistics knowledge and you're a chemist, you're good. Make sure you do at least 1 year. I don't care how much you do, but you must know what the word statistics is and do some of it. Do at least a year. Don't find it by accident like I did. Then I thought the next year, women in analytics, because one of the boys, I've got 3 sons. I said, why do you just care about the woman? I said, it's true, actually. In this country, you can't just say unemployment, shame, poor woman. No, unemployment's everybody. So I thought of dudes and data. And because this woman's hair is numbers, I thought of a boy spitting out water. And I was told it looks like he's vomiting. But in any case, I'm not changing him because I trademarked him. So that's dudes and data. So I do a program where I say, schoolboys, schoolgirls, this is what analytics is. Know about it. It's called statistics. Do it at university. It's if you're an engineer and you've got an opportunity doing another module, do the statistics if you can. Because the more, I'm not saying be a statistician, use statistics in your discipline of choice. Make sure, I mean, be an astrophysicist, whatever, but learn some statistics. And then for teachers are change agents. Let me grab teachers. So I'm going to tell the teachers, because I've worked a lot with subject advisors. They're the ones that train teachers for the Department of Education. I did lots of projects up there. So I must tell the teachers about data analytics. So I did this one, and I thought this was quite nice. It's a nurturing hand of a teacher. And you'll see there's a rocket taking off, and there's some graduates sitting there. So it's the teachers pushing us more graduates through. So that's that plan. And then last year, I did my final one, data analytics for industry. I had a business breakfast where I got businessmen in, and I got postgrad students and academics, and to talk together. What can we do to improve the rate at which students move into industry, but in a way that immediately they can be job ready and also have the skills to be able to continuously grow in industry, because it will keep changing. So we had lots of discussions, try and get bursaries for students. That's all students are interested in, but also to find out what can they tell us that we don't know to improve our programs. So that was the last year I conceptualized. You can see every year was one, and we have them every year. So this is my program from last year. I think it was 2023. Yeah, this was where I really want to show you the level at which this is pitched. This is for school kids, grade 11 and 12. John Baylor, if International Stats Institute, ISI, is the highest statistics body in the world. He's a president 2 years ago of ISI. Do you know that he was prepared to speak to the school kids in South Africa and to be interviewed by them? He said he wants them to ask him questions, to interview him. Can you believe it? The president of the highest statistics body in the world was prepared to be part of our dudes and data. So I was really very proud of John Baylor and really appreciative. He did a fantastic job. And we actually did like a online Zoom session, put them in different rooms, the boys and the girls, women in analytics parallel to dudes and data. And then to balance with this very amazing man, I got the wonderful Jennifer Priestley. You wouldn't know her. She looks like a model, but she's amazing. She's Vice President of Business Development, Visa, EU in London and MasterCard, analytical consultant for Accenture Strategic Services Group. But she's one of the top 12 data scientists to watch in 2016. Yeah, it was a few years ago. But she was also Distinguished Stats Professor of the Year, and she architected the first PhD program in data science. And it's at Kennesaw State University. I went to visit her, I went to see her, and that was actually what we mainly put our masters, our coursework masters were mainly what we learned from our visit to Jennifer. And she came out to visit us, to see our program, and to speak at the first launch of Women in Analytics. So really, when you get world-class speakers prepared to speak to school kids, Jennifer was there for the schoolgirls. She's actually done it 3 times for me. She gets up at 2 in the morning if I have a morning event. So people are taking seriously what we do. People want to help South Africa and want to help developing countries, and we just have to do it as best we can. So you can see. So really, this is just to say it's not just me alone. I'm in the background there. This is our secretary. We pack bags. We do lots of things to make the teachers happy. And we work with top people. Christine Franklin, she is the American Stats Association ambassador, the highest you can be for statistics education across the whole America. She's chairs of the guidelines for assessment instruction in stats education. That's the world top standard for how you should assess statistics. She helped me write a workbook for school teachers that I use when we train school teachers. So that's Christine from University of Georgia in Atlanta. And she came out as well. And we did a survival pack, which is for the change. We tell teachers, you change agents, you're the ones that can change it for learners. And she did the workbook with me. She gave a motivational talk online, but she also came out physically the first time. Materials, video. We did a SAS data flow workshop with a SAS software we got free. All teachers got it. And yeah, poster competition for teachers. It really was huge. And this is an example of SAS Data Fly. Nombuso Zondo, one of our young lecturers, did the workshop with all the stats lecturers helping. And this is important. You'll see Ethiopian delegation. Prof Zewatar from Ethiopia. We're trying to spread data literacy wider. It's not just about solving it in Durban. So we always involve other countries, trying, because then if you want international people to help you, and you've got some knowledge, you should be helping other countries as well. So that is what we do. And at the next year at The Hague, the World Stats Congress, we're inviting more of the other African countries to come and see what we do, and we share with them as well. So yeah, that is what we do for our SAS Data Fly. We know what we're doing. We're serious about helping these Christine in South Africa with our teachers. We also go to other universities. I went to Western Cape with my team and also to Northwest University and repeated the entire Teachers for Data Analytics for them. And Christine came online when we went to them, but we've helped them run it as well. And the plan is that they would then continue, giving them our materials. So in conclusion, statistics education lessons that I've learned that bring success. You've got to have well thought through strategies if you want to build increased capacity across the full data skills value chain. But it starts, most importantly, with getting the bottom right, planting seeds at base level. And you've got to work with teachers. They change agents. Now you've got these lovely programs and the business wants them, and the students that are there that happen to find statistics can be the ones that will benefit from all your contacts with industry. It's just not on. You've got to make sure that more come in from the bottom, because we don't want them to be graduates that will end up working in professions that they didn't study. Then you've got to link with experts in the field, nationally and internationally, and also through South African Stats Association. I've got many good friends like Prof Dash yesterday, International Stats Institute, and so on and so on, World Stats Forum. Go to all of those. We keep going to them to see what we can find. And we link with industry. We want our students to engage in unstructured big data projects to solve real industry problems, because they get invaluable experience, but it also goes on their CV. To ensure relatively trained stats graduates for the data era are produced. So importantly, no knock and drop. You know that saying, that's what my African students tell me. Knock and drop means you just quickly tell them about it and you run away. The Afrikaans, you know the game tok-tokkie. Jy weet as jy klein is en jy speel tok-tokkie, jy kruip klop en jy kruip weg. That's called tok-tokkie. English, we say knock and drop. We don't do knock and drop. You go there, you help them, you go back the next year, you go back the next year. So that's very important. Okay. So you got to repeat, and each time you repeat, you refine and you improve. So build your brand as relevant statistics educators for the data era across the full data skills value chain, and then protect your brand. All my emblems, everything I've got, I have properly secured, but at the same time trademarked. I'm happy to work with anybody that wants to work with it as well. So I'm just saying, because that's something I learned from Padilla Hotler with the Maths for Stats campaign I did with him. Once you say to people, okay, there it is, they mess it up, but your name is attached to it because it's your brand. So anybody can work with our brand, but they work with us and they do it the way we want it done. Or else they do their own one with their own brand. Okay, that's the end. I hope I've said something that's of some value to you.
Yeah, thank you very much, Delia. I'm sure your colleagues here will have lots of questions. Are there any questions for Delia? Here we go.
Okay, something I've noticed. When I was in school, I was never really exposed to machine learning specifically. So, what is the first point of contact with machine learning for typical students in South Africa? And should it be moved earlier? Should it be moved into schools, for example? What do you think?
I can just tell you, at our university, they touch on it at third year, but really at honors, they start because they are going to be big unstructured data projects. So they certainly do, they do at honors level explore more explicitly, but really we don't do research as such into machine learning. I think that's more on the computer science side. We definitely ensure that every student is very well versed in how to use it, when to use it, and so on. So it's really, I would say, at honors level and not really before.
But should that be moved earlier, you think?
Yes, but I think with time, but we really just have it for the big projects that they do in data. They have boot camps. We do have boot camps for our honors students, which third year students can come to, where it will be, they'll be exposed to that as well. And many do come.
Thank you.
Thanks, Delia. Sorry, in terms of the outcome of employability, what has been the experience? So it's nice to have 400 graduates coming, but when they leave, do you keep in touch with them? Have you kept any records of that and seen what the experience has been?
Yeah, keeping in touch with students is very difficult. We do give them their UKZN email lifelong. And what we generally find is that they'll be very excited to tell you where they're working, and then it drops off. We do struggle to keep it. What we've been very successful at, the ones, of course, some do keep contact with us. We do try and keep, but we get them to speak to our students on our days where we have learners coming in, and it's often online. We put the students into groups, and then some of our students that work in the Durban area, they will come and be prepared to be someone that will speak to the students. We do use our students for that. So they do, and if it's online, we get more that participate because we break our students into little groups, even the school kids, and then they can interact with senior students, with people in the workplace, and we try and make it young people in the workplace. Yeah, just before I go off that topic, a good thing to do if you ever do something similar, you do speed dating. You know, speed dating where you speak, people are in a group, and after 5 minutes, the group changes. So we have, say, 10 or 12 students that are in the workplace. And then you have, say, 10 students in each group, and they can ask questions. And after a few minutes, you swap it, and then they with another student, and they can ask questions. They found that very, very enlightening, and they really enjoyed it.
Hello there, how are you?
Well, thank you.
I'm good. I would like to ask a question with regards to what you call those of elementary and younger students. I think what happens is a lot of them gets scared of basically maths and all that. And by the time they reach high school, a lot of them will be more terrified of, say, like the maths paper and statistics. How would you go about combating that, if I may ask?
Okay. Not being a teacher, I work with teachers. I think that the best way is to do it through games. Most of the statistics education projects are sort of fun activities so that they're learning statistics through playing a game. And I think that is most probably the best way to do it. It doesn't feel like they're being examined. We ask them, they're part of a game, and while they're playing the game, they're learning statistics, if you know what I mean. And I'm thinking of an example. For example, we had lots of pictures of ladybirds. They call them ladybugs in the US. Christine Franklin came with this one, where they have a picture and then you have the little dots and you try and see what's on the other side, and they're recording it. And then if they find a matching one, they put it on the other. It was sort of, and you do little graphs. for ladybirds with 3 dots, with 4 dots, with 5 dots, and then you try and figure out, it's sort of a gamify. It's a game, but you're learning how to record data and how to think about the outcome, what it could be, and whether you're right or wrong. There are various games like that. And I think to learn without realizing you're learning is really the key. So there's no pressure on being right or wrong. It's just a game.
Thank you.
Delia, hi. We had a number of comments that basically said that, people are saying, thank you very much, excellent talk, really insightful. But we had one question, somebody's asking, where can they study stats online? So I'm guessing somebody is employed. This question from Lucius Mankonko.
I would think UNISA would be the right place. We are a face-to-face university, though our postgraduate data science degrees are in blocks. There are parts where you have to come in, and there are parts that are online, but it's not a fully online data science degrees. So our postgraduate data science degrees are in blocks, where for a part you have to come onto campus, and we try and make it like, say, 4 days or whatever when they do pracs and so on. But generally, it's face-to-face, but I would think UNISA would be the right place to study statistics online.
If there are no more questions, Delia, it's my pleasure to thank you very much. And there's a little sign of our gratitude. This is a magazine that NITheCS co-publishes. Yeah, so it's about mathematics. So thank you very much for coming. Thank you very much.